Hello everybody, thank you for joining us this evening. This is the second part of the public event of the inaugural Forming and Exploring Habitable Worlds meeting at the University of Edinburgh. I'm very happy to see so many friendly faces in the audience this evening, and also, of course, there are so many of you online. It's wonderful to be able to share this. This talk will be recorded, so it will be available permanently on YouTube. I'm delighted that the speaker for the second part of the evening is distinguished Professor Chris Impey. Chris has had an amazing career. He's won a number of awards, several of which were for his contributions to teaching in particular. He's an alumnus of the University of Edinburgh, so many years ago he gained his PhD here as an astronomer associated with the Royal Observatory of Edinburgh. Since that time, Chris is, he's currently based at the University of Arizona, where the Steward Observatory is, and a number of his colleagues are here in the audience. He's going to give a talk which is loosely based on one of his many popular books that he's written. In this case, it's his book is Beyond, Our Future in Space, and the title of the talk as given here is Our Future Off Earth. So I'm sure that we'll hear about all sorts of concepts as concern how we explore space, why we explore space, what we can and what we should or should not do. Thank you very much.
Okay, welcome everyone. It's great to be here back in my hometown, as it happens. All of you physically here, and I know there are virtual people as well, and you're just as real to me as well. So I'm going to talk about something that seems a little hypothetical and far in the future, but isn't really, which is our future off Earth. And I got interested in this subject, though I'm a research astronomer, really an educator, because it seemed like something was going on. And so I wrote a book about this a few years ago, and things have moved even faster since then. So I'm going to talk about the stuff you're reading in the newspapers pretty much every week. But I'm also not going to paint a rosy picture on it. This is not a wholesale positive thing. And there are very mixed views about the whole idea of us living off Earth, spending money, traveling in space, and so on. And so I'll get these caveats up front, and I'm not going to address all of them. I'll try to address somewhat. But they remain in view. Billionaires with boy toys, who cares? We have pretty big problems here on Earth, and it's why are we spending so much money trying to leave the place that we should be taking care of better? Space is just an unnatural place to be. There's no question about it. We were not built to be in zero gravity or in a total vacuum. And so the cost of insulating us from that is extreme. And the corollary is that robotic probes do all this much better and 20 or 30 times cheaper. So why not just use robots or machines? Space junk is getting worse. So the penalty of going into space and with large numbers of satellites, and there are now microsatellites, is that you have a huge problem. And then the cultural slant on this is that what if we just go off Earth and repeat all the horrible things that happened with colonialism when the Europeans went to the New World and elsewhere, and pretty bad things happened. Maybe we're just going to play this horrible story out again in a larger arena. Well, that's all a big downer, so I'll be a little more positive. First of all, what am I talking about? I'm not talking about the Star Trek, interstellar travel, your favorite science fiction. I'm talking about really just near Earth. Near Earth orbit. Earth orbit is a day's drive, half a day's drive straight up. It's not that far. Traveling in the solar system, to give you a scale model, just to get a sense of it, Earth, a golf ball, moon, a pea, arm's length. The solar system, a few kilometers across, and the nearest star, not even on the Earth, 50,000 kilometers away. So interstellar travel is totally beyond the pale with current technology. It's just not on the table. And it's expensive too. Adjusted for inflation, the moon landings cost about a $250 billion. And that was just to send 24 people to the nearest rock in space, and 12 of them walked around a bit and brought it back a few hundred kilos of rocks. And it was over half a century ago. Most people on the Earth were not alive when that happened. So it sort of seems like we've lost our way if that was what we were supposed to be doing. I will make a case, a mild case, that we are built to do this. This is the history of human migration around the planet in thousands of years, leaving Africa, extraordinarily rapid migration across the planet. Other species travel large distances for food, migration, for mating, and so on. We're the only species that travels when we don't have to, not for food or survival. I always look at this and I'm amused because in this incredibly rapid migration across the land bridge from Siberia, which existed then, down through the Americas, we ended up in Patagonia. It's a pretty crazy place. I've been there, and even in the high summer, it's pretty wild. Well, somewhere along the way, they went through Southern California. Why didn't they just stop and say, okay, this is fine, we'll just stay here? Why do we have to go to Patagonia or South America? So it's a little crazy, this migration across the planet. And here's a research study from some years ago that correlated the incidence of a particular allele of a gene that's, of course, been dubbed the explorer gene. Not that genetics could ever be reduced so simply, but it correlates the amount which human populations have migrated with the incidence of this gene. The natural occurrence rate is about 10%. And so you can see what happens. The people with this particular variant of a gene migrate more. It's associated in modern populations with ADHD and risk-taking behavior, jumping out of planes and base jumping. Richard Branson has it, of course, no surprise there. So are we built to explore? Is going off Earth just an inevitable implication of the fact that we've explored the planet and now we need to go up and out? I don't know, but I'll just put it out there. I won't give a long history of the space program, just a few little points that you may not be aware of. First, primate in space, Miss Baker, a spider monkey, 1959. Miss Baker lived to the age of 29, that's old for a spider monkey, and was buried with full military honors at Goddard Space Flight Center. 3,000 people went to the funeral. You should be so lucky to have 3,000 people at your funeral. I'm sure you know that most of the first landmarks in the space program were set by the Russians. The first, of course, first person in orbit, first woman in orbit, first landing, soft landing on the moon, the first satellite, etc., first spacewalk. So America in this duopoly of space was losing badly in the first years. And space travel is dangerous. This is an incident that happened in 1960 at the Russian Space Center, and it was hidden, it was covered up, what happened for 3 decades, essentially. It's called the Nettling catastrophe, after the field marshal, who could only be identified by a partially melted. It was the incineration of a rocket. About 100 people died instantly in the fireball, and another 100 died from the poison gas that was created when the rocket fuel combusted. So about 250 people died. And this wasn't going into space, this was just on the ground. So it can be dangerous. Also covered up and not very well publicized. And more recently, a Long March rocket went off course and killed probably 2,500 to 3,000 people in Chinese villages that happened to be in the wrong place. So we did go to the moon. It was a long time ago. It's hard to believe. There's evidence of it because in the country I live, 9% of people think the moon landings were faked. I hope there's someone in the audience that thinks that. It always occurs to me that in a supermarket checkout with a dozen people back home, one of them is an Apollo denier. It makes me want to go forget my groceries, go down the line, figure out who that is, and change their mind. So as an educator, it's off, of course. On the other hand, if you made a list of the batshit crazy things that 9% of Americans believe, Elvis, the grassy knoll, whatever, then maybe I shouldn't get so bent out of shape about Apollo deniers. So what's the state of space? It feels like, or did until recently, like it was in the doldrums because it had this very strange geopolitical history with 2 superpowers vying for supremacy. And less than 700 people have still been in Earth orbit. More than 10 times that number have stood on top of Mount Everest. So it's a pretty small group. 24 have been to the moon. And again, 50 plus years since that happened. So you look at the big stepping back, and it doesn't look like we're doing that well. But this is an early stage of a very difficult technological challenge to go into space. So we have to take the long view. And also, people who criticize NASA should be mindful of the fact that when we went to the moon, NASA's budget was almost 5% of GDP, unsustainable. And of course, the last 3 moon landings were canceled as the bills for Vietnam came due, and NASA's budget went into reverse. More dispiriting for astronomers and space scientists is this factor of 2 decline in NASA's budget in real terms in the last few decades. So people expecting NASA to do more with less, it's a little unreasonable. And NASA can obviously still do some pretty cool things. The little Mars rovers, James Webb, they've had some big successes. They also have a PR problem because they really only get into the news when something blows up or they need more money. Less obvious to many people because it's part of their secretive military-industrial complex. The Chinese space program is going gangbusters. The Chinese are just on the verge of finishing their space station, and the International Space Station could well just deorbit and disappear in a couple of years. Chinese are going to the moon. They've been to the moon. They're going to Mars. They're doing all these things. Until recently, the budget for their space program was increasing at the rate of their economy. That's doubling every 5 years. Compare that to NASA's budget. And this is the new superpower rivalry. And we don't know a lot about that. And that worries some people because the issue of nukes in space is still a real issue. And we don't know everything that the Chinese are planning or are up to. So that's a concern. But the things you're really reading about, of course, are the private sector and this new commercial space industry. And it had its antecedents in something called the X Prize that was a couple of decades ago. It was a challenge prize to go into Earth, to go to the edge of space, 100 kilometers, the Kármán line, and then repeat it a week later. And of course, the teams that were competing for it spent far more than the prize was worth to do it. And it's modeled after the prize that Lindbergh won in 1927, which also involved people spending far more to do a transatlantic solo flight in a small airplane than the prize was worth. But it seeded this activity. And what we see now is a direct consequence of things like the X Prize. We, of course, know the triumvirate of space moguls, billionaires, all of them. Richard Branson, the local one, known to everyone here, of course, he's a publicity hound. He's had a disaster, of course, and his program was slowed down for a couple of years with the death of a co-pilot and near death of a pilot when their spacecraft came apart. Blue Origin, also less publicized because Jeff Bezos likes to stay below the radar, but they've also had a lot of successes, and that rivalry of SpaceX and Blue Origins is a very intense rivalry and a very evenly matched one, despite what you may read in the papers that skews it so heavily towards Elon Musk and SpaceX. Their technological capabilities are very similar. And Bezos, of course, has been nice if you can do it. He's been cashing out $1 billion in Amazon stock every year to keep his company afloat because there's no revenue coming in to speak of. SpaceX, don't have to say anything. He's in the paper all the time. Most of us are getting kind of jaundiced with Elon Musk these days, but he does know his stuff. He's an engineering physics PhD. He's a rocket scientist. He knows this stuff. He's not just bloviating. And he has now had 110, I should have updated that number, successful launches of the Falcon 9 rocket with no failures. That is impressive. So he is doing his stuff. And he's also been savvy enough to partner with NASA to resupply the space station with goods and recently astronauts. First time America could get astronauts into orbit after a decade of the space shuttle being grounded. And he's getting multi-billion-dollar contracts from NASA, and that's sort of keeping him cash out stock too, although he's just spent $44 billion on Twitter, which means he's probably relatively poor. And so these are the people, and they're not all familiar to everyone. Burt Rutan was the architect of the plane that won the space prize, poached by Branson for his company. There's Branson. Peter Diamandis, also not well known to most people, started the X Prize Foundation and a series of challenge prizes, not just the X Prize in space. some biotech ones. Elon Musk doesn't need any introduction. There's Jeff Bezos. Yuri Milner's put $100 million into this, a Russian philanthropist, billionaire. And if you see you get the idea to be a space mogul, you need some Eastern European male pattern baldness thing going. If you don't look like that, you probably. And these rockets are big. This is a indication of how Elon Musk's next big rocket, his BFR, and yes, the F stands for what you think it does, how it stacks up. And in terms of cost per launch, it's 100 times cheaper than the space shuttle and 300 or 400 times cheaper than Saturn V. Reusable rockets is a game changer. And that's what Elon Musk and Jeff Bezos have essentially been able to do. And, you know, you can still fail. This didn't happen overnight, and it wasn't without problems. These were the first attempts to reuse a rocket. I think I've lost the sound, actually, but it doesn't matter. The visuals give you it. So this was the attempt to reuse a rocket and land it at an offshore site, so you didn't endanger the population. Witness the Chinese Long March rocket going off course. And so space travel is still hard. Things go wrong. And these were the many failed attempts of SpaceX about 5, 6, 7, 8 years ago until it hit its really good string of successes. And Elon Musk's philosophy, which he's been very public about, is to go fast and break things. And it sounds cavalier, but they know what they're doing as well. And the argument has been made that NASA was always too conservative. A kind of jaded senior NASA engineer wrote a book where he essentially argued that in the way they function, NASA had costed the value of an astronaut's life at about $1 trillion, because that's how much they stress safety and how their precautions stop them from being adventurous. Astronauts sign up knowing they're going to die. Death rate in space is 2%. It's about the same as base jumping. So, you know, there are dangerous things we do on Earth that are as dangerous. 2%, you know, that's a significant risk, but all the astronauts that have ever been up are willing to take that risk. And so people will die. And if we're using as our model commercial aviation, the graph, you don't have to be able to read the details, but the graph shows the death rate, fatality rate per billion miles flown, which declined by a factor of 30 or 50 or 100 to the present day. Circles are little innovations in avionics like redundancy, pressurization of the cabin, et cetera, et cetera. So the bet here is that the arc of commercial spaceflight will follow the arc of civil aviation, which in 1930 was expensive, dangerous, and hardly anyone could afford to do it, and hardly anyone did it, and it didn't seem like it was for everyone. That's the bet. But people will die. There's no question about it. Interestingly, the American government in particular has put a very light hand on the rudder. It is very lightly regulated industry. You are essentially going to sign a waiver if you go up on these rockets, and they are immune from any kind of liability or civil action. So they can take risks, and the people who sign up will assume the risk. The economics are interesting too, because as we see, it's billionaires doing it for the most part. And there's a number of world's billionaires, you know, dispiriting if you've watched your savings sink or the stock market go up and down. Number of billionaires is increasing fairly rapidly. And of course, any of them can do this. Elon Musk, Richard Branson, and Musk have all spent $1 billion plus of their own fortunes on space. And these collectively, these billionaires are worth $12 trillion, an extraordinary amount of money. And not coincidentally, from Forbes this year, the 2 richest people in the world are running the 2 prominent commercial space operations. They can afford to do it. And they have the long game in view. They will not be deterred. Elon Musk says he wants to die on Mars. Well, he says a lot of things, but they're both in it for this kind of strange, quasi-mystical, visionary idea of us leaving the Earth, really leaving the Earth. And they just view what they're doing now as the first steps along that path. They really do believe in it. They've drunk the Kool-Aid. Now I like to think, since this is about first space program now, it's about recreation and tourism and so on. It's not really about exploration and science, unfortunately. So you make the analogy with movies and entertainment, and I went to the source of all information, Wikipedia. NASA didn't have this data. I actually had to get the space missions from Wikipedia as well. So this is the average cost of all space missions and all movies for over half a century. And there's high, there are high marks, expensive things, and then there are cheap things, Discovery missions and so on. And then there's the movies, and the same thing. There's some movies that were more than average and some less than average. Ben-Hur was very expensive. And so this is the average. Train spotting, local reference. Made right here in Edinburgh, choose life. So train spotting, incredibly good deal. And the ones that I like to compare directly, because why not, are right there. So if you had $250 million burning a hole in your pocket, you could get a really cool movie from a good director, James Cameron, about life on an exomoon. Or you could build the Kepler satellite that found hundreds of Earth-like habitable planets. It did it for real. They cost the same. To skeptical audiences of science, I say, this is why science is actually a pretty good deal. And to analogize, maybe you don't want to push this too hard, you can vision 4 phases of the internet activity, and I'll compare it to space. I'm sure nobody knows who this is. J.R. Licklider in 1960 wrote a white paper for the RAND Corporation that fully envisaged data in the cloud, the wireless internet, your iPhone, at a time when mainframe computers were about a tenth the size of this room. I think extraordinary. So there are visionaries in these fields who see the future very clearly. It's incubated by the military-industrial complex. The first people with email worked at military installations and research facilities that had military contracts. Eventually, it moves into the research arena, universities and research institutes. In 1995, we can really put a punctuation mark. So in 1995 is the big bang of the internet, and that's the year 2 graduate students at Stanford figured out search. It's the year a company with a strange name, Amazon, was formed, and it was the year of the first internet service providers, none of which still exist. So here's space, same thing, pioneers. Robert Goddard, tiny thing at the top of the stand is his rocket. Traveled 160 yards across his Effie's frozen cabbage patch, a bitterly cold winter day. And could you vision a straight line from that to the rocket that went to the moon? Maybe. But there is a straight line. It's the same technology. The technology hasn't really fundamentally changed. It's incubated by the military-industrial complex. Wernher von Braun. You don't always want to know how the sausages get made. Wernher von Braun knew that the Russians were coming, and he was smart enough to surrender to the Americans. They spirited him back to the US. They scrubbed his Nazi connections. Von Braun was in charge of the Middle Works rocket factory, where 7,000 slave workers died, and his V2s rained down on London and killed another 7,000 or 8,000. He had a ton of blood on his hands. He was sanitized, the public never knew about it, and he became the architect of the NASA rocket program and the father of the Saturn V rocket, an incredible rocket, of course. And then it moves into the research arena with the shuttle and the space station. And so I don't say there's a year that's analogous to 1995 for the internet, but sometime around now, we are going through that membrane where it takes off. The internet economy is now worth $5 trillion a year. And there are white papers that say that the commercial space sector is going to be worth $10 billion a year by the end of the decade. And that's probably about right. So this thing is moving fast. I'll just, as an aside, mention that it's not all about putting people into space and joyrides. The miniaturization is giving us nanosats and microsats. It's lowering the bar such that student groups, undergraduate student groups, can launch real scientific experiments, putting them together in a launch capability. It's pretty extraordinary progress. Of course, the number of these things is growing a little rapidly, which is why low Earth orbit is getting cluttered. And there's the projection for global satellite launches for a few years ahead. And that is a problem. No question about it. What's the legal framework for this? I said the regulatory framework is extremely loose. And the legal framework is loose too. There have only ever been 2 United Nations treaties dealing with space. The Outer Space Treaty, which banned weapons in space, we hope it sticks. And the Moon Treaty of '79, which was not signed by the major superpowers, which dealt with ownership, but only by governments. It's mute to corporate entities and private individuals. So basically, all bets are off. It's a Wild West. You can own anything you want. So there are no rules up there, actually, at all. The junk problem is a serious thing. Space junk is increasing, and there was a dire paper written 2 decades ago by a NASA engineer in a Kepler scenario where the space junk collides and turns into smaller pieces, and it exponentially increases until low Earth orbit is unusable. We're not really at the Kepler scenario, but we might be in 10 years, because this is the classic tragedy of the commons, where there's no motivation for anyone to refrain from the activity that's eventually going to ruin it for everyone. And we're still figuring this out, because cleaning up space junk is extremely hard. There are various technologies that have been tried, harpoons, space nets, magnetic, whatever you want. And many big satellites deorbit naturally now. But the problem is really bad. And that's something that, if there are 2 trillion bits that are 1/10 of a millimeter, and you might say 1/10 of a millimeter, who the hell cares? Well, moving at 30,000 miles an hour, 1/10 of a millimeter can ruin your day. So, this junk is all over, and low Earth orbit is threatened by it. We also have the issue of contamination, which NASA is now taking seriously. I'm really envious of anyone else's job, but I met the guy, and it's been a woman too, over the years, who has the incredible name badge with NASA logo, Planetary Protection Officer. And that is a cool job. I would like to be a Planetary Protection Officer. So NASA takes seriously not trashing Mars or places we go with Earth microbes, and very seriously what happens when they come back. We are currently staging moon rocks to return to the Earth by the end of the decade. They will be taken very securely to Johnson Space Center. It's a level 4 biohazard containment facility, and no one's going to take any chances, even if Mars is or the moon is dead. No one's going to take chances. So you should be reassured about that. But the larger issue of how we treat space, given there are no rules, is still an issue. Is it going to be some extension in the American model of the great parks and preserving them and keeping them intact and pristine? Or is it going to be some neo-colonial thing, which, will be somewhat less salubrious? But we're moving fast. This is just last year. Records just set last year. Investment at the record level, the most successful launches to Earth orbit since Sputnik ever. The most people in space at once. For a few minutes, there were 14 people in space. It's never been true. The youngest astronaut, Walter Damon. The oldest astronaut, William Shatner. So 2021 was a banner year. And here's the long arc of the space program. On the top, you see the government launches, the hustle between the United States and the Soviet Union. The Soviet Union, was big into this activity, but they're kind of obviously second world country heading maybe even further down at the moment. They can barely afford their space program as it is, and they're not breaking any records now. Under the line, you see the commercial launches, and you can see how they've just grown steadily, such that 2016 was the first year there were more commercial launches to Earth orbit than government launches. And if you just put a number on it, the number of Earth launches to Earth orbit, the blue bar is this year. So we anticipate busting the record that was already set last year for the most Earth launches. So maybe this year is the 1995 of the space program. What's really driving this is the cost per kilo to Earth orbit. And this is a logarithmic scale. So it is truly impressive that in a single decade, mostly SpaceX, reduced that cost by a factor of 10. That's exponential improvement in something that's just hardcore physics and engineering. That's hard to do. It's not like IT stuff. Bits and bytes are cheap and electrons are cheap. This is hard to do. And if you project this curve, then you get to the point where it literally will only cost, a regular vacation's worth of money for you to go into Earth orbit. And if we ever build a space elevator, it essentially becomes free, because a space elevator transports material to Earth orbit with solar-powered lifters, no rocket fuel required, no rockets required. So this is the way we're headed, if you can trust that kind of extrapolation. What's on the horizon? Well, all sorts of things. Like I said, we don't get to control what happens on the moon and Mars, so there'll be rovers there, there'll be commercial activity, there'll be, it's not going to be wonderful. Advertising, astronomers are really worried about big neon signs in Earth orbit and elsewhere that are going to mess up the sky, because the satellites, the constellation of satellites are already messing up astronomy at the research level. So this is how it's going to go. If we could get a space elevator, that would be spectacular, because the space elevator, I'll just summarize it briefly. Arthur C. Clarke was the visionary behind this idea. And he was asked once, when do you think we'll get a space elevator? And he said, 50 years after everyone stops laughing. Well, people have stopped laughing. So what is a space elevator? It is a very strong cable that is played up into space, not just to Earth orbit, because that's only 300 miles, but it's played up to a quarter the distance to the moon, because at that height, the centrifugal force of the cable, the centrifugal force upwards, balances the weight and the load down. So it just hangs there like an Indian rope trick. Incredible. It's possible, that's the physics, it's simple. The engineering is brutal, but it's not impossible. So how far are we from a space elevator? On the moon's 1/6 gravity, we could build a space elevator with current technology. Carbon nanotubes, the best, the purest, could have the tensile strength to support the weight of a lunar elevator. A space elevator on the Earth is a lot harder, but it will probably happen. And the cost of these things have been costed at 10, maybe $15 billion. It's not a lot. That's a tenth of the space station. It's just not a lot of money. And the commercial possibilities are enormous, because it would enable the industrialization of space. Whether you think it's a good or a bad thing, that's what it would do, because it would lower the cost of, just for a little physics here, without getting into physics, the energy cost of going to Mars, 55% of that energy cost is just getting the first 300 miles to Earth orbit. So that's the hard part. So the space elevator takes that out of the picture by giving you an instant way up with solar-powered lifters. So it's an incredible thing. And you build things in Earth orbit and then move them around the solar system. From the moon, you build industrial capability on the surface, and then you construct things with 3D printing and robots in Earth orbit. People don't have to do this stuff. The technology is very good. So I think a stairway to heaven is on the cards. It is going to happen at some point, and probably first on the moon, where it's viable right now. And mining asteroids, another visionary, dreamy, scary, crazy sounding thing. The economics of this are that there are 100 near-Earth asteroids, over 100 now, that are about a half a kilometer across. And any one of them, and especially the judiciously selected ones, would supply platinum group metals worth $2 trillion and the same value of rare earths. And rare earths, as you know, are now strategically critical resource, often in the hands of countries that the West doesn't get on that well with. And huge industrial activities depend on rare earths and the platinum group metals, enormous. Most of modern life depends on it, basically. Every electronic device you have depends on it. So the ability to mine an asteroid in situ, so how do you do this? Well, you take one of these near-Earth asteroids and you redirect it into a loop, not an Earth orbit, that takes too much energy, but into a looping Earth-Moon orbit, cislunar orbit. And we can do that. NASA's just demonstrated its asteroid redirection technology as a way of protecting the Earth. Now, this is going to be in the hands of the kind of cowboys that, were the gold miners 150 years ago and then put derricks in the Texas panhandle. Do you trust them to bring that asteroid into a perfect near-Earth orbit and not nail us? And that's all she wrote for civilization? Okay, so there's some issues here. I'd rather trust NASA with that project than the industrialists who want to mine an asteroid, but it's going to happen too. The speculation that, the simple trite phrase is that the first trillionaire will be an asteroid miner. And a lot of people will lose their shirts before that happens. But basically, this is going to happen. Also, water is a very expensive resource to bring up, to lift up from the Earth. It's heavy. And you can get the water in situ. And water is all you need to colonize the moon and Mars and elsewhere, because you need the water, of course, to drink and for growing things. You separate the water and you have the basis for rocket fuel and the oxygen to breathe. So water is a critical resource, and there's tons of it in hydrated minerals and in frozen ice forms in an asteroid. Again, judiciously selected. So this is going to happen too. And notice I haven't put a time frame on the space elevator, but let's say a decade on the moon, 30 years, one on the Earth. Mining an asteroid, 20 to 30 years. Proof of concept coming soon. And then we will be able to live on these places. It won't be a precarious toehold. It will actually be the ability to have sustained human habitation of Mars. And it may not be done first by governments. It may indeed be done by the private sector, where they're going to do their own social experiment, and it'll be unregulated. It could be dystopic or utopian. It'll be like your best and worst science fiction as it plays out. So we are going to go to Mars. Again, the time scale is 20 or 30 years for a true colony. And Mars, of course, as we know from the movies, is beautiful. Also, these people are going to we should think about who self-selects to be a Martian colonist. They're going to aggressively modify their own genes. They're going to hack their own genetics. They're going to use medicine with nanobots. They're going to 3D print tissues, bones, and organs and do all this kind of thing. They're going to be totally bleeding edge on biotech, because that's, of course, the kind of people who self-select to be in these programs. And Mars, shame we don't have the sound because there's nice tranquil music here. So Mars is beautiful. This, of course, is Morocco, but it stood in for Mars in The Martian. And so it's going to be a beautiful place to go. And you're not going to see out really, because to protect from the radiation, you're not going to be in a nice dome looking out at the landscape, because you'll have to be battle hardened with a 1 meter thick regolith building blocks made from the Martian soil, and they'll just have holograms to show you what it really looks like outside. It's too dangerous to be outside. But of course, Mars has a sting in its tail, and when things go wrong, they go really badly wrong. So again, same story, people will die, and it's just going to be part of what happens. People died when they explored the Earth, when they went up the tallest mountain, when they did all of these things for the first time. So yes, Mars has a good side and a bad side. And just to put it in view, although I said I was only going to talk about plausible space travel within the solar system, we can just draw a through line to the possibility of going to the stars. And it's not going to be us for generations. But at least at the level of nanobots, there's a project called Breakthrough Starshot, which is planning to do it right now. Their website lists about 25 engineering challenges, and they're extreme engineering challenges. They have very smart people, and they're just sort of solving them one by one. And the basic idea is to take extremely powerful microwave arrays, to beam microwaves into Earth orbit, so 100 terawatts worth of power from lasers, and focus them onto solar sails that are probably a few meters square. And the solar sails are attached to nano spacecraft, a gram or so. And because of the boon of miniaturization in electronics, you can have a 1 gram spacecraft that has biosensor, that has a camera, that has an antenna, a transmitter, biosensing chips, and so on, in the tiniest possible package. It's incredible. So there won't be one. There'll be fleets of these things, because you're going to accelerate them with this enormous power from Earth orbit to 4 or 5% of the speed of light. And you're going to send them to Proxima Centauri, which is the nearest star system, where we already know there's a likely Earth-like planet, and there might be more than one. And so they will do this amazing remote sensing experiment at 5% of the speed of light, 4 light years, do the math, 80 years. It's a multi-generation experiment, but they plan to do this in the next 10 years and send those first fleets out. With their feeble transmitters, it'll be like a fire chain. They'll have to send the information back at light speed to the next wave of nanobots, and then eventually gets back to Earth. But it only takes light speed, so 4 or 5 years to get the information back once the fleet arrives. So that's us going to Proxima Centauri. Okay, it's not as exciting as people going there, but we use remote sensing. That's how we get around the solar system. these clever machines, these robots, these cameras, they're extensions, they're physical extensions of our senses. And humans have always done this. Maybe it's nicer and cooler to go there. It's more dangerous, more expensive, but these will be our sense extenders. If you want to do it with people, well, that's just a lot harder. I mean, if we want to do the projection, it's always so fun to project on a log-log plot because it means nothing. But here's the history of maximum speed that humans have ever achieved by any means or conveyance. And you might imagine extrapolating this, that we might generate that a speed to get to Proxima Centauri with large payloads like humans in a 50 or 100 years. And yes, that's possible. Now, humans will not be able to survive that, so we'll also have to develop the suspended animation technology. And then, even then, it's a little tricky. So you're going to have to get this little dystopic thing going on where people are still too big and the energy cost is too high. So we'll probably send frozen embryos to Proxima Centauri, and they'll be raised by robot nannies when they get to their destination. It sounds, I don't know, I know how that sounds, but there are people who are going to do this, right? Because that's sort of the only way to do it, plausibly. So is that going to happen? Well, I'm starting to get less clear now. I'm not willing to project or extrapolate more than a couple of decades. Of course, we will leave the Earth, and eventually we'll leave the solar system. If we take the long view, if we don't, we're shooting ourselves in the foot in so many ways. It's hard to enunciate them all right now as humans on the Earth. This parlor situation, we're in tribalism and wars and threats of nuclear weapons. The bullets of the atomic scientists, the doomsday clock has been sitting at 100 seconds to midnight, the closest it's ever been to midnight in the atomic age. And, you don't want to think too hard about that. There's no clear indication we'll make it out of our trouble as adolescents, as a species. But if we do, technology is moving apace. And so you can imagine that any civilization like ours that had the capability to travel to the stars at a few percent of the speed of light, doesn't have to be relativistic Star Trek stuff, couldn't colonize the galaxy in a short fraction of the age of the Earth or the age of the galaxy. And, in 1950, Enrico Fermi used the same logic as time, before the space program even existed, when computers barely existed, to make the same logic and say, well, if we are going to be able to do it in 100 years, doesn't matter what the number is, if we're going to be able to do it fairly soon in a cosmic timescale, why should we be the only or the first? That's pretty good logic. And so he flipped it and said, well, where are they? They should be out there. Why would we be the first? Do we see signs of them? Where are they? So that's a provocative question raised by the arc of our technology and the trajectory that we witness all around us. So let me wrap up and come again to the prospects, again, the good, the bad, and the ugly, because I don't want to sugarcoat this too much. Is this going to be recreation for the masses? Well, yes, at the point where it costs less than a nice cruise to go into Earth orbit, a lot of people are going to do this. When I teach a large class in Arizona, I poll the undergrads, 18 to 20-year-olds, and I say, what fraction of your eventual salary would you pay for a once-in-a-lifetime trip to Earth orbit for a few days, assuming it's as safe as driving a car, which of course is a lot more dangerous than flying in a plane. And a lot of them are willing to spend a significant chunk of change, and we run a little economic model, and it shows revenue just from US millennial population of about $20 to $30 billion a year. That's the same as the gross receipts of Hollywood. So I make my entertainment analogy right there again, directly. In fact, we have an audience, so I shall ask the question. If going to Earth orbit for a few days were as safe as driving a car and as cheap, though it's not cheap, as a nice cruise, put your hand up if you do it. Okay, so that's about 2/3, half to 2/3. And that's similar to what I get with a big class of 18 to 20-year-olds. So there's a market, obviously. Now, I'm not going to, invert and sugarcoat this, but because clearly we have to take care of the home planet. But there is a slight silver lining that the technologies we will have to use and prototype to live independently on the moon or Mars are models for parsimonious living on the Earth, by definition, because you have to use everything in situ, you have to be completely conserving all your resources. And so there are lessons that are going to be learned out there that are relevant to down here. Mastery of the solar system, yes, that's on the radar. I'll give you a little use for the space elevator. The space elevator will be able to take our toxic or nuclear waste in large amounts, hundreds or thousands of tons, into Earth orbit, and then give it a little extra push to leave the Earth forever. And that's better than bribing African countries to take it, which is what the West has done for decades, or sinking it to the bottom of the ocean where it may or may not be safe, or putting it deep in Nevada or whatever. So we have a potential problem to solve in there. Now, as a scientist or just a social scientist, would be very interested in all these social political experiments that will come into play, because this is an offshoot of the human experiment in a new arena. It's as momentous as our first steps out of Africa in terms of who we are. The modeling of the genetics of it suggests that a minimally viable, diverse genetic population, which is about 100 to 120, will, after about 200 generations, have evolved so differently to be almost a new species. That's speciation at a very rapid level because of the unusual environment. Won't even put in the modification they'll do to their own genetics. So it's very interesting, and the social side of it is equally interesting. What communities will happen there? Read the Red, Green, Blue Mars trilogy by Kim Stanley Robinson if you want to see this played out on Mars by a really good writer. So these are interesting to me to imagine. And then we just have this area where there's new people, there's new effort needed. We need some space lawyers, we need space ethicists, of course, because why would we let this be an untamed Wild West where the worst instincts of humanity are played out? We need policy, we need wonky people to figure out the policy. So all of this is going to happen alongside the rockets and the headlines and Elon Musk taking all the oxygen out of the room. So be prepared for this in the next few decades. And remember that in the long view of the space program, this is by no means the end. It's just the end of the beginning. Thank you. Into questions.
Yeah, questions are invited for those that are online and also those in the room.
Thank you very much, Chris. I contend, by the way, you made a case for no cells. Is it time for Plan B? You've just made a case for that. For the rest of you, I'll tell you about it later. But anyway, the question I wanted to ask you really is that I contend that sending a sail all the way to Alpha Centauri is going to be practically impossible. The reason behind it is very simple. Space is cold and full of water, and all the water will actually stick, and it's the stickiest liquid around, stick to the sails. By the time it gets to Alpha Centauri, it probably be the size of Alpha Centauri itself, and it will be slowing down, no matter how many lasers you point at that sail. So that's my challenge to do it.
Right. And I'm not going to speak for Breakthrough Starshot. Those are issues that are listed on their website, and they don't.
Oh, right. Okay.
For them. The space is not a complete vacuum, correct? And so there is drag, there is degradation, and they're using, of course, the idea of huge redundancy in this fleet to partially offset that. But you're right; these are serious issues. I recommend their website because it's a fascinating combination of hard-nosed engineering and design and this sort of lofty, visionary, almost mystical ethos. So it's an interesting project.
There's a question from online. How can you determine the estimate time to colonize the galaxies? As scientists doing moon landings in the 1960s predicted that by now we'll have a base on the moon already. So how do we adjust for the shifting timeframes?
Right. So this is an arena, and I've done it throughout the talk of sort of willfully and blithely extrapolating where extrapolation is not always warranted. So yes, the history of the space program does not encourage naive extrapolation. But I think the point about the first 50 or 60 years of the space program is it was a very strange beast. It was a geopolitical experiment born out of a superpower rivalry. So the reason, as it's well known, the reason the U.S. went to the moon was born out of that rivalry, because the Russians had been kicking American butt for the first 5 to 7 years of the space program. So I think that's very strange, and artificial history sort of colors how we view it in hindsight. If we look at the history, recent history, as the commercial sector has started to take off and are sort of masters of their own fate if they solve technical problems, I think it's a little more reliable. Elon Musk overstates how many people he's going to put on Mars. I mean, that's just pure PR. But he doesn't overstate the capabilities of his rockets. They are extraordinarily capable rockets. And if he gets economies of scale in the construction of those rockets, then the game is on.
Thanks a lot. Interesting talk. Entertaining talk at that. I'd like to ask you, since you really know your stuff about it, what was the last time you were surprised by technical development, or the other way around? What would really surprise you if we solved it in, let's say, 10 now, 15 or 20 years time?
I mean, I think the technical achievement that I see on the horizon that I'm surprised by, because the engineering involved is so clever, is the space elevator. So Arthur C. Clarke's, people will be laughing for half a century. The engineering studies that were done a few decades ago, they're quite mature, and so they've just been much more successfully than Breakthrough Starshot with their extraordinary ambition. Those challenges have been met and are being met, and that was surprising to me because that sounded very fanciful. The other thing I would say that doesn't get much airplay or attention is that the technologies required for suspended animation of humans are also moving apace. They're obviously born out of the medical profession, about people who are, revived from falling through ice on a lake, or they're having their body fluid replaced momentarily, their blood. So experiments that have been done with pigs and dogs have taken them down to the point of cryogenic freezing, not fully cryogenic freezing, replacement of the body fluid, and reanimation after weeks, and in a couple of cases, months. Now, the failure rate is pretty high. I mean, I like pigs and dogs, so I don't like to see pigs and dogs die. But those models are moving, and they're pretty good human models, pigs and dogs. So I think suspended animation as a possibility. NASA has a big research project studying the tardigrade, the water bear, because it does cryptohydrosis, and it takes its body water down to 1% of normal, forms a ton. And indirectly, there's evidence that they can handle that for centuries and possibly millennia. Tardigrades survive deep space environment, incidentally, a couple of times. So suspended animation could well surprise all of us.
Any questions? Agree or online?
There's somebody on the line, online actually. Somebody called SM.
Oh, that's nice. So this big question is coming from a PhD student from Egypt. Oh, he's originally Egyptian and he's currently based in Russia.
Yeah, thank you very much.
Is that Mohammed?
May I have a question?
Yeah,
Yeah, it's me. It's
question?
Mohammed. Yeah, it's Mohammed. Can you hear me?
Yep, we can hear you.
Okay, perfect. Thank you very much for the presentation. It was very nice and very fruitful of information. Just like I have a question. As a person who is doing research and involved in the research, like in the space industry and space research, I believe in space exploration, and I know that space exploration means a lot for all of us actually, and we can explore a lot in the future. But many of my colleagues that they are not involved in this industry, or in this field of science, they are always asking a question: why so many people, especially rich people, don't prioritize solving the problems on Earth first, such as climate change, disease, poverty, hunger, and lack of education in some areas. I mean, even if we spend a lot of money on space exploration, how we can, from your point of view, compromise this situation or like this problem? Like actually, like sometimes I can answer this question to my colleagues, but I don't have the perfect answer usually. How we can compromise between spending a lot of money on space exploration and solving some problems on our planet?
Sorry, and could you summarize that? I was only imperfectly hearing the question.
I'm not, I didn't entirely hear everything there, but I think that the crux of the question was concerning the balance between the private sector's role in space exploration and the government's role, and how there are different points of view on this, and how we come to a point of reconciling that, if we can indeed control that.
Right. So, I mean, there's an ugly truth about the sort of capitalist Western society we live in, that regardless of what you think of the activity, the people who are doing it are going to do it anyway. Maybe they're spending your money. Jeff Bezos sort of made a misstep when he went up, came down, and thanked all the people who used Amazon Prime. His publicist should have said, no, that's not a good look, Jeff. You shouldn't say that. But they are going to spend their money on it, and we can't really gainsay it, and we can't even regulate it, or it's not being regulated. So I'm not going to judge it good, bad, or evil. I'm just going to say, regardless of what we think of it, it is going to happen. Now, at the level of governments and societies, we do get to say how it happens. And NASA, I know well, and less well other space agencies, but they all have a fairly even-handed view of it. And, unbeknownst to most people, out of NASA's $18 billion budget, about $3 to going on $4 billion of it are spent looking at the Earth and caretaking the Earth. So NASA is not putting all its money into rocket design, and very little actually in rocket design. So some of these agencies are taking care of the planet, or have a balanced view of the exploration versus caretaking and guardianship. And NASA also, to again its credit, has been sponsoring workshops and convening experts and trying to juice up and gin up a new activity of space ethics and space law to get people involved that are not doing the activity themselves, but are thinking about the implications and aware of the downsides. So I don't trust governments to do that, government agencies to do that perfectly, but I think they are motivated to do it. Space junk, another example. Everyone knows that space junk is a problem for everyone, and all the space agencies are working actually together to try and figure that one out.
Thank you very much.
Okay, so I think this concludes the second part of the public event. I'd just like to say a really special thank you to Matt Mark, who has been taking care of all of our technical needs. Because it's always a team effort. There's a significant committee behind this entire meeting, so I'm not entirely sure how I can ever thank them, but they've done an amazing job. I guess that's it, really. These have been some really uplifting talks, I think, all evening here. So I've really enjoyed that personally, and I hope that everybody in the audience has taken a lot from this too, and will be inspired going forward. Thank you very much, Chris.